In this video, we'll begin our discussion of section 11.7, which is talking about different coordinates, besides the one that we traditionally studied throughout grade school, which is our rectangular coordinates, x, y, and then we introduced this semester, z. Those are called rectangular coordinates. The first thing we're going to extend to is something called cylindrical coordinates. Back in Calc 2, hopefully, not all Calc 2 teachers get there, we have a coordinate system called polar. And what polar is in two dimensions. We have, instead of x, y, we have r theta. And what r is r is your radius. So you go out, whatever that is, r. And then to get to your point, you take that and you rotate it, whatever theta was. So your new point is right there. So that is your point. So none of this is actually there, but that's how you get to it, is you extend to r, whatever r is, and then you rotate it around. That is polar. Now, going to 3 dimensions, to cylindrical, thankfully, if you haven't studied polar, you get to study polar now. You can go do that because the extension to cylindrical is just adding a z component by lifting it up. If I use right angle trigonometry, I can call this r, and then I know my point is x and y, and I know this is theta, and I can get to these equations here. Think about taking cosine of theta. Cosine of theta, cosine is adjacent, so that's x over r. If I multiply both sides by r, I get x equals r cosine theta, which is that first equation. The other way would be to use that same triangle there, and you can do sine theta equals, and that's going to be opposite over hypotenuse. Multiply both sides, we get y, oops, took me all the way out, y equals r sine theta, and that's that second equation right there. Weirdest arrow I think I've ever drawn. There we go. And then z, they just let z be z. So that's how we convert from cylindrical to rectangular. So if they were giving me a point and it was an r and theta and z, I could use this to convert back to x, y, z. They're not going to be the same, and you can see that here. So this point here is x, y, z. This is our extension to cylindrical, is we have an r, some type of r, it rotates around to this r, and then we raise it z. One thing I do want to point out about this, and that's this note here, but we'll keep talking about the other stuff. R is not the distance from this point to this point. It's not that distance. It's the origin, the big point there, to this big point. That is R. So like R comes out, it's like out here, and then we swing it theta, and we come up. Well, R is the distance projected from the point. That's another way to think about it, and that's what that statement says, is if I were to project this point here down, like sunshine, noon sun straight down on it, that is R, that distance here. If I have rectangular and I want to get back, okay, well, if I acknowledge the triangle that's here on the screen, this triangle, I have a triangle, this point is x and y, and then that distance is r. Well, I get the Pythagorean theorem from that right triangle, right angle being there. I also get tangent. Tangent is opposite over adjacent, or y over x, and then z is z. So that is going the other way around. So there are conversion formulas. The coordinate system, we're going to talk a little bit more. This is just a formal way to talk about it. Let's get to our example. All right, so it says convert the following point from cylindrical to rectangular. Hold on, there's a noisy truck passing. I'm outside again. It's nice today. All right, so we have this point. This point is in cylindrical. All right, remember, I always write down the cylindrical. Okay, that's R is 3. This is what I meant, write down the cylindrical points. Theta is negative pi over 6. And then z is 2. All right, well, I'm trying to get to x, y, and z. So I can write down anything that doesn't change. Well, that z doesn't change. And then I use my formulas. One thing I think you should do is think about what quadrant this is in and write it down, because this is going to help us answer a question a little later. Think about this positive r, right? It goes to the right, and it rotates negative pi over 6. So here's my xy. It goes r to 3, and then it rotates over this way. So it's right here in quadrant 4. So I'm going to write that, quadrant 4. And then the z goes up, keeping it in quadrant 4. We also call these octants, and it's 1, 2, 3, 4, and then 5 goes under 1 and follows the same pattern as 1 going up. So this is actually octant 4 as well. All right, so we use our formulas now. So x equals r cosine theta. So 3 cosine negative pi over 6. That goes down. That is a small triangle there. Cosine is an x value for that. So this is equal to 3 times radical 2 over 2. That gets me 3 radical 2 over 2. Y is r sine theta, which is 3 sine negative pi over 6. This rotates down again. And it's a small triangle. Sine is my y value, so that tells me it goes down. It's negative 1/2. So my y value is negative 3 over 2. There we go. So the point is 3 radical 2 for x, negative 3 over 2 for y, and then I'm going to write my answer. I would like you to do stuff like this to prep for tests in your homework. Just write it clear where you can see the answer. Practice like you're going to test. Don't practice sloppy because you'll test sloppy. So please be as clear as you can with your homework. Act like somebody's going to read it. All right, I have one more example going the other way, and then we'll talk about another coordinate system. So here's our second example. It says, from rectangular to cylindrical. All right, so this is rectangular, so x is rad 2, y is negative rad 2, and z is 4. And we want to go to, okay, cylindrical is I'm way ahead of myself. This was 4. Cylindrical is r equals theta and z. All right, z doesn't change. But now I'm going to use my other formulas. So r squared equals x squared plus y squared. So I got r squared equals, okay, x is square root of 2. Y is negative square root of 2 squared. So we get r squared equals, okay, that's 2. And 2, we get 4, which tells me r is 2 and negative 2. All right. To get our theta, because that's all we need now, we have tangent of theta is y over x. So that is tangent of theta is negative rad 2 over 2. All right, if I didn't write all that in. Negative rad 2, and then what was x? X was rad 2. That's what it was. All right, so we get tangent of theta to be negative 1. All right, we get two angles here for negative 1. We have 3 pi over 4 and 7 pi over 4. All right, we're looking for when x and y are the same. And I know the radian thing, I know you guys are probably whining about that, and that's okay, I understand, but we got to get used to it. It's just how it is in calculus. So 3 pi over 4, 7 pi over 4, and we're starting to get we have a bunch of different answers now. I have 2 r answers, 2 theta answers. What we're going to do now is go back and think about where the point actually is. This is an x, this is a y, and that's a z. So this is x positive in the x direction, so we're going positive in the x direction. Let me grab a different color. Positive, negative in the y direction, and positive in this direction. So that is quadrant 4, and then octant 4 because it's the same thing. Octant 4. All right, so when I pick answers, they have to be in the same one. So if I pick a 2, that means it's extending. Okay, here's my axes. It extends 2 out, right? And then we're thinking, does it need to turn here or here? Well, it would need to be in quadrant 4. Well, 3 pi over 4 gets me here. So to go all the way around, that would be that 7 pi over 4. So it makes sense when I'm choosing out of these two that it's going to be 7 pi over 4 with 2. So there's a note to make if you'd like to write it down. The 2 positive one, because maybe you're wondering, well, what the heck does that go to then? Well, the 2 will always, the positive one will always go with the angle that puts us where it should be. Okay? So it should be the angle that will work. Now, we have that for our answer. We actually have 2 different ways to get to this point. And if you don't remember that from polar, it's kind of odd because rectangular doesn't do that, but polar allows us to have multiple points, infinite number of points for the same thing. We could have also chosen -2, 3 pi over 4. These 2 points are exactly the same. I would recommend thinking about that, doing a radius, a theta, and thinking about your z's, and think about why are those the same exact point.